Hello, in this lecture we'll answer on two questions. In the first question, we'll find out the area of the green shape, and in the second question, we'll find out the radius of this circle that blocks triangle ABC. So we'll start with the first question. In the drawing, we have a big circle, and it is given us the question that AB is the diameter of the big circle, and the radius of the big circle equals to 13 units, and the big circle blocks triangle ABC. Actually, triangle ABC is inscribed by the big circle, and triangle ABC blocks the small circle. The small circle is inscribed by triangle ABC, and we also know that the radius of the small circle equals to 4 units, and we want to find out the area of the green shape. So first of all, we will define the center of the small circle as point O. We will define the point of tendency of tangent CB with this small circle as M. We will define the point of tendency of tangent AC with this small circle as N. And we will define the point of tendency of tangent AB with this small circle as L. In the next step, we will join points O and M together by a straight line. O is the center of the small circle. M is a point on the small circle itself. Therefore, OM is the radius of the small circle. And so we define the radius of the small circle as R, and R equals to 4 units according to what is given us in the question. Again, point O is the center of the small circle. Point N is a point on the small circle itself. Therefore, ON, it is also defined as the radius of the small circle that is equal to 4 units. Okay, so here we also have a rule number 1 that states that a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here the radius ON, it is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent AC with this small circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NO. So AC is perpendicular to NO. It means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Likewise, we have the radius OM that is drawn to the point of tendency, that is to say it is drawn to point M, that is the point of tendency of tangent CB with this small circle. And whenever we have a radius that is drawn to the point of tendency, then according to rule number 1, tangent CB will be perpendicular to the radius MO. So CB is perpendicular to MO. That means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay? And we also have another rule that states that any peripheral angle that that rests on the diameter of a circle equals to 90 degrees. So here the peripheral angle ACB, rests on AB, that is the diameter of the circle. Therefore, according to the rule that I mentioned, the peripheral angle ACB equals to 90 degrees. It is a right angle, it is equal to 90 degrees. So actually, in quadrilateral ONCM, we have 1, 2, 3 right angles. So I write it down. In quadrilateral ONCM, we have 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MON. This angle, in total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So we subtract 270 degrees from this equation, and we get that the missing angle MON equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay? So this angle MON, it is a right angle, it is equal to 90 degrees. So actually we found out that inside quadrilateral ONCM, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So I write it down. We relate to quadrilateral ONCM as a rectangle. Quadrilateral ONCM is a rectangle. Why? Because it has 4 right angles. Okay. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of a rectangle NOCM, they are equal to each other. That is to say, NO equals to CM. NO equals to CM. But we have already found out that NO equals to 4 units. It is the radius of the small circle. So here we can write down that NO equals to 4 units. And from this equation, 4 equals to NO equals to CM, we derive that CM is also equals to 4 units. CM is also equals to 4 units. Here, CM equals to 4 units. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that OM equals to NC. OM equals to NC. OM equals to NC according to the rule that the opposite sides of a rectangle are equal to each other. But we have already found out that OM equals to 4 units. It is the radius of the small circle. So we can write here that OM equals to 4 units. And from this equation 4 equals to OM equals to NC, we will derive that NC is also equals to 4 units. NC equals to 4 units. So all the sides of quadrilateral ONCM, they are equal to each other, they are equal to 4 units. Therefore quadrilateral ONCM is not a rectangle but a square. Okay, so in the next step we will define side AC, triangle ABC is A, AC equals to A, AC equals to A according to our definition. Okay, side AC of triangle ABC equals to A according to our definition. We will define side CB as B. CB equals to B units according to our definition. So here CB equals to B units, and we will define the diameter AB as C. Okay, the diameter AB equals to C according to our definition. So what is the length of line segment AN? From the drawing it is very easy to see that AN equals to CA minus NC. Again, CA minus NC equals to AN. I write it down. AN equals to AC minus NC. So AN equals to AC minus NC. So AN equals to AC equals to A according to our definition, and NC equals to 4 according to what we have already found out. So in conclusion we found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. In the same way we find out the area of the the length of line segment MB. From the drawing it is very easy to see that MB equals to CB minus CM. CB minus CM. Yeah, MB equals to CB minus CM. So MB line segment MB equals to CB, CB equals to B according to our definition, minus CM. See, we already found out that CM equals to 4. So in conclusion we found out that MB equals to B minus 4. So we can write here that MB equals to B minus 4. So if we found out that MB equals to B minus 4 and AN equals to A minus 4. In the next step I will present to you rule number 2 that I already mentioned in the past, according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again, the lengths of two tangents from a common external point to a circle are equal. So if we focus on the common external point, point A is the common external point in relation to the small circle because it is not located inside this small circle nor on the small circle. Therefore it is common external point. This is defined as a common external point. So from point A we have two tangents to this circle, tangent AL and tangent AL. And according to rule number 2, the lengths of those two tangents they are equal to each other. That is to say, AN equals to AN according to rule number 2. But we have already found out that AN equals to A minus 4. So we can write here that AN equals to A minus 4. And from this equation, AN equals to A minus 4, we will derive that AN is also equals to A minus 4. AN equals to A minus 4. Here AN equals to A minus 4. In the next step, we will focus on the common external point, point B. From the common external point, point B, we have two tangents to the small circle. So the common external point B, we have two tangents to the circle. The first tangent is tangent BN, and the second tangent is tangent BM. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BN equals to BN according to rule number 2. But we have already found out that BM equals to B minus 4. Here. BM equals to B minus 4, so we can write here that BM equals to B minus 4. And from this equation, BL equals to BM equals to B minus 4, we will derive that BL is also equals to B minus 4. BL equals to B minus 4. So we can write here that BL equals to B minus 4. So actually we found out that BL equals to B minus 4 and AL equals to A minus 4. And we know that AB is the diameter of the big circle. So AB is a diameter, it's twice as long as the radius. So if the radius of the big circle is capital R, then the diameter AB must be equal to 2 times capital R, but it has been given us in the question that the radius of the big circle equals to 13 units, so R equals to 13 units, therefore 2R is 26 units. This is to say the diameter AB equals to 26 units. So here AB, that is also equals to C, it is equal to 26 units. So from one side, the diameter AB equals to 26 units. But from the other side, the diameter AB from the drawing, you can see that the diameter AB equals to AL plus LB. The diameter AB that is equal to 26 units equals to AL plus LB. Okay. So the diameter that is equal to 26 units equals to AL equals to A minus 4 plus LB that is equal to B minus 4. So in conclusion, we found out that according to equation number 1, the diameter AB that is equal to 26 units equals to A minus 4 plus B minus 4. So according to equation number 1, we get that the diameter AB that is equal to 26 units equals to A plus B, and we have minus 4 plus minus 4 is minus 8. Okay, so in conclusion, according to equation number 1, we found out that 26 equals to A plus B minus 8. Here we subtract, we will add to this equation, equation number 1, 8. And we get that according to equation number 1, A plus B equals to 34. So here we square this equation, equation number 1. And we'll get that according to equation number 1, A plus B squared equals to 34 squared. Here we'll open the brackets on both sides of this equation, equation number 1. And we'll get that according to equation number 1, A plus B squared equals to A squared plus B squared plus 2 times AB, and it is equal to 34 squared, that is 1156. Okay. Actually, we know that triangle ABC is the right triangle because of the fact that angle ACB, this angle equals to 90 degrees. So we can implement the Pythagoras theorem of the right triangle ABC. So, in the right triangle ABC, by PT is the expression for Pythagoras theorem. We get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse of triangle ABC is AB, so the square of the hypotenuse is AB squared. And it is equal to the sum of the squares of the perpendiculars, so it is equal to AC squared plus BC squared. So in conclusion, we found out that according to question number 2, AB squared equals to AC squared plus BC squared. So here AB equals to 26, therefore AB squared is 26 squared, that is 676, and it is equal to AC squared. AC equals to A, so AC squared is A squared, plus BC squared. BC equals to B, so BC squared is B squared. So actually in conclusion, we found out that according to equation number 2, 676 equals to A squared plus B squared. So because of the fact that A squared plus B squared equals to 676, it means that we can substitute A squared plus B squared in this equation number 1 by 676. Okay, and we get here, according to equation number 1, A squared plus B squared, but A squared 676 according to equation number 2, plus 2AB equals, actually here we have plus 2AB equals to 1156. So here we subtract 676 from this equation number 1, and we get that according to equation number 1, two times AB equals to 1156 minus 676, it is equal to 480. So I found out that 2 times AB equals to 480, and we divide this equation number 1 by 2, and we get that according to equation number 1, AB equals to 480 over 2 is 240. So here we divide the equation by 2, and we get that AB over 2 AB over 2 equals to 240 over 2, that is 120. So A times B over 2 equals to 120. So what is the area of the green shape? The area of the green shape equals to the area of triangle ABC minus the area of the small circle. So I write it down. The area of the green shape, actually blue shape, the area of the blue shape, equals to the area of triangle ABC minus Repeat again. The area of the blue shape equals to the area of triangle ABC minus the area of the small circle. Okay, the area of the blue shape equals to the area of triangle ABC minus the area of the small circle. So the area of triangle ABC equals to the base of the triangle, that is AC, times the height to the base, that is CB, over 2. Minus the area of the small circle, that is pi r square. So the area of triangle ABC equals to AC, that is A, times CB, that is B, over 2. Repeat again, the area of triangle ABC equals to A times B over 2, minus the area of the small circle. The area of the small circle equals to pi r square when r equals to the radius of the small circle, that is 4 units. Okay. We have already found out that AB over 2 equals to 120, therefore we can substitute AB over 2 in this equation by 120 minus pi r square, r equals to 4 units, therefore r square is 4 squared, it is 16, and the area of the small circle equals to pi r square, so it is 16 pi. So in conclusion, we found out that the area of the blue shape equals either to 120 minus 16 pi square units, or in terms of numbers, it is equal to 69.73 square units. Okay, I'll repeat again. We found out that the area of this blue shape equals to either 120 minus 16 pi square units, or in terms of numbers, is equal to 69.73 square units. We finished with the first question. In the next step, I will present to you the second question and resolve the second question in 3 different methods. So in the drawing, we have the circle and the triangle ABC is inscribed by this circle. We know that the area of triangle ABC equals to 9 square units, side AB of triangle ABC equals to 5 units, and side BC of triangle ABC equals to 6 units. And we want to find out the area of this, the radius of this circle that blocks triangle ABC. We'll start with the first method. From point A, we draw perpendicular on BC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as D. So we actually know that the area of triangle ABC equals to 9 square units. It is given as the question. And the area of any triangle equals to the base of the triangle, in this case is BC. The base of triangle BC is BC times the height to the base. The height to the base is AD because AD creates 90 degrees with the base BC over 2. I repeat again. The area of triangle ABC equals to the base BC times the height AD over 2. It is given as the question that BC equals to 6 units. So we substitute BC by 6 times AD over 2. So in conclusion, we found out that according to equation number 1, 9 equals to 6 over 2 is 3. So 9 equals to 3 times AD. Here we divide this equation number 1 by 3, and we get that according to equation number 1, AD equals to 9 over 3, that is 3 units. AD equals to 3 units. Here AD equals to 3 units. In the next step, we'll focus on the right triangle, triangle ABD. On the right triangle, triangle ABD, according to the Pythagoras theorem, here by PT is the abbreviation for Pythagoras theorem. The square of the hypotenuse equals to the sum on the square of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is AB squared. That is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD squared plus BD squared. I repeat again. In the right triangle, triangle ABD, according to the Pythagoras theorem, A squared equals to AD squared. According to the Pythagoras theorem, AB squared equals to AD squared plus BD squared. So AB equals to 5, so AB squared is 5 squared, that is 25. That is equal to AD square equals to AD square. So AD equals to 3, so AD square is 3 squared, that is 9, plus BD square. BD is the missing 9 segment, so we leave it as it is. So I actually found out that according to equation number 1, 25 equals to 9 plus BD square. Here we subtract 9 from this equation, equation number 1, and we get that according to equation number 1, 25 minus 9 is 16, and it is equal to BD square. So BD square equals to 16. Here we take out all of this equation, equation number 1, and we get that according to equation number 1, BD equals to the square root of 16, that is 4. So BD equals to 4 units. You can write down here that BD equals to 4 units. Okay? So what is the length of line segment DC? From the drawing, it is very easy to see that the length of line segment DC if DC equals to BC minus BD. BC minus BD. So DC equals to BC, BC is 6, minus BD, BD is 4. So in conclusion, DC equals to 6 minus 4, that is 2, that is to say, DC equals to 2 units. DC equals to 2 units. We can write here that DC equals to 2 units. In the next step, we will focus on the right triangle, triangle ADC. On the right triangle, triangle ADC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, therefore the square of the hypotenuse is AC squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to DC squared plus AD squared. Okay, so found out that in the right triangle ADC, according to the Pythagoras theorem, AC squared equals to DC squared plus AD squared. So AC squared equals to DC squared. DC equals to 2, therefore DC squared is 2 squared, that is 4, plus AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, so in conclusion, we found out that AC squared equals to 4 plus 9 is 13. Here we take out all of this equation, and we get that AC equals to the square root of 13 units. AC equals to the square root of 13 units, so we can write here that AC equals to the square root of 13 units. In the next step, we will define the center of this circle as O, and then we will join points A and O together by a straight line. And then we will extend line segment AO by a straight line until it touches the circle. And we will define the touching point of the extended line segment AO in this circle as E. Here AE is chord that passes through the center of the circle, Therefore, AE is defined as the diameter of this circle. AE is the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius, so if the radius of this circle is defined as capital R, then the diameter AE will be equal to 2 times capital R. So AE equals to 2 times capital R, and AE is the diameter. So here we'll join points B and D together by a straight line. So here we created angle ABE, peripheral angle ABE rests on AE, that is the diameter of the circle. Any peripheral angle that rests on the diameter of a circle is equal to 90 degrees. Therefore, angle ABE that rests on the diameter AE must be equal to 90 degrees. So this angle ABE equals to 90 degrees according to the rule that I mentioned. We'll write it down. Angle ABE equals to 90 degrees. So here we have also another rule. According to the following rule, if two peripheral angles rest on the same chord, they are equal to each other. We can also say that peripheral angles that rest on the same chord are equal to each other. So here we have those two peripheral angles. They are both rest on the same chord that is called AB, therefore they are equal to each other. Okay, so here